Hello everyone, let's understand what is rolling motion. To understand rolling motion, we have to first understand what is translation motion and what is a rotation motion. In translation motion, at any instant of time, all the particles of the body have same velocity. In other words, if a line is drawn between any 2 points of the body, that line will remain parallel to itself during the motion. On the animation on the left hand side and on the animation on the right hand side, we have connected 2 points by the line and we see that line remains parallel to itself. The animation on the left hand side represents a rectilinear motion and the motion on the left hand side represents a curvilinear motion. So, translation motion can be of two types, rectilinear motion and curvilinear motion. Next is rotational motion. The simplest example of the rotational motion is we see in our home, in our daily life, is the rotation of the fan. The rotation of fan is an example of the rotation about fixed axis. Every particle on the body moves in a circle and the center of all the circles lie on the straight line. The body is in pure rotation and this fixed line is known as axis of rotation. Another example of rotation motion is the rotation about a point. In this case, the axis is not fixed but pivoted about the point and this axis itself is rotating. For example, if we take this example of top, each and every particle on the top is rotating about its axis, that is the green line, but the axis itself is rotating about the red line, which we can say is a vertical axis. The important point here is the bottom point of the top is not moving on the ground, that is the top is not slipping on the ground but it is fixed. So we say that this rotation is about the fixed point. Next, any motion of a free body can now be decomposed into two independent motions, and that is translation of center of mass and rotation about axis passing through center of mass. If we take this example of a pencil lying on a table and we take it, what we see here is that the center of mass is translating in a straight line and the entire pencil is rotating about the axis passing through center of mass, and this is because of the Newton's second law of motion. According to Newton's second law of motion, the acceleration of the center of mass of the body is in the direction of the external force. So if the body is free to rotate and translate, the only possibility is that the body is only supposed to rotate about the axis passing through center of mass. Now let's come to the special case of rolling, which when we consider the combination of translation and rotation motion of the objects like ring, disc and sphere, we see the rolling motion, and this rolling motion is again a combination of the translation motion and rotation motion. On the left hand side we see the wheel, which is purely performing a translation motion, and the right hand side wheel is purely performing a rotation motion. When we combine these two motions of translation and rotation, we will get the rolling of the wheel. So here what we see is the wheel on the top is doing a pure translation motion and the wheel in the middle is performing a rotation motion. The third wheel, which is basically the superposition of the translation and the rotation motion, is performing a rolling motion. We can classify rolling motion into two categories, pure rolling and impure rolling. To explain the concept of pure rolling, I have taken a wheel which is wounded on the rim of the wheel. Now when the wheel is performing a pure translation motion, the thread or the rope does not get unwinds on the rim of the wheel. Whereas when the wheel is performing a rotation motion, as we see in the left hand side, the threads gets unwind from the rim of the wheel. Let's assume that in the time t, the wheel translates a complete distance of 2 pi r, which is equal to the circumference of the wheel, and in the same time the wheel has completely rotated by an angle of 2 pi. If v center of mass is the velocity of center of mass, then v center of mass into t is equal to 2 pi r, and if omega is the angular velocity of the wheel, then omega multiplied by t is equal to 2 pi. Eliminating t, what we get is v center of mass is equal to omega r. This is the condition for the pure rolling motion. So when the wheel translates a distance of 2 pi r, the wheel also rotates by a complete angle of 2 pi such that the thread completely unwinds from the circumference of the wheel. This is what we can see in this animation. In the given time t, when the wheel has completely translated a distance of 2 pi r, the wheel is also rotated by an angle of 2 pi. As a result, what we see is that the thread gets completely unwind, and this distance, which is equal to 2 pi r, is the length of the thread, and by that time this wheel has completely rotated by an angle of 2 pi radian. Next, consider the example of impure rolling. We take the example of a impure rolling when in the real life scenario, if we see, when we suddenly apply the brake to the vehicle, what happens is our vehicle of the wheel of the vehicle starts skidding, and in this case what happens is the wheel is translating with the same velocity, but the rotation of the wheel slows down. As a result, if we take the time t in which the wheel has translated a distance of 2 pi r, what happens is, since the rotation has slowed down, the wheel does not rotate an angle of 2 pi. As a result, part of the thread remains unwind over the wheel. If we see here, this is the angle by which the wheel has missed the complete rotation, and this is the same amount of the thread which is not unwound from the wheel. As a result, this distance, which is equal to the unwound length of the thread, and this distance the wheel has skid in the forward direction. So what we see here is the time t in which the wheel moves forward the distance of 2 pi r is equal to v center of mass into t, and the angle theta with which the wheel rotates in this time is omega into t. Now because the wheel is not rotated by the complete 2 pi radian, this theta is actually less than 2 pi, or we can say that omega t is less than v center of mass into t divided by r, or we can say that v center of mass is greater than omega r. So in this case of impure rolling, the translation of the center of mass is greater than the rotation of the wheel. So here we get the complete picture of the impure rolling, of the skidding of the wheel. The upper wheel which we see is translating with the same velocity v center of mass and travels a total distance of 2 pi r, but the wheel does not rotate by the angle 2 pi in the given time, and hence the starting point has not reached the initial point, and this distance is actually equal to the thread which has not unwound over the wheel, and as a result the wheel has skidded this much distance in the forward direction. Another example of impure rolling is the case where our wheel gets stuck into the mud. In this case, what happens is, what we see is that the wheel starts rotating at the same point, or it's rotating more and translating less. As a result, what happens is the thread is unwinding at a greater speed and the wheel is moving forward with a lesser speed, or what we see here is, by the time the complete thread is unwound, the wheel has moved a distance which is less than 2 pi r, but the complete thread length, which is 2 pi r, has been unwounded, and when we take the complete distance 2 pi r, what we see is the wheel has rotated an extra angle, and here what we see is that V center of mass into T is the distance which is travelled, and in the same time it is rotated by an angle 2 pi, which is equal to omega into T. What we see is that V center of mass is less than omega r. We can see this in this complete animation. The wheel at the top has translated a distance of 2 pi r, but the wheel has not the wheel has not translated a distance of 2 pi r. By the meantime, the wheel has completely rotated by angle 2 pi, or when the wheel has made a translation of 2 pi r, the wheel is rotated by an angle which is greater than 2 pi. Or in this case, omega r is greater than V center of mass. So what we have seen is that for pure rolling, V center of mass is equal to omega r, and in impure rolling, V center of mass is greater than omega r for skidding, and V center of mass is less than omega r for slipping. Thank you.